Have you ever just sat and thought about endings? And I don't mean like, oh no, we're out of milk endings. I mean like the end of everything.
It's a pretty profound question, isn't it? One that humans have grappled with for as long as we've been looking up at the stars.
Totally. And speaking of stars, that incredible video you sent over from Arte, the one about, well, the end of the universe, it really got me thinking about that on a whole other level.
It's a fascinating area of cosmology and physics. And while it might seem like something straight out of science fiction, we're actually starting to get some clues about how the universe might eventually, you know, meet its end.
It's wild, right? Going from what's for dinner to what's the fate of the entire cosmos. Talk about a jump. So how do we even begin to wrap our heads around something as massive as the end of the universe?
Well, to understand where it all might be going, we have to start at the beginning. And thankfully, we don't need a time machine for this. Telescopes, powerful as they are, have become like time machines for us, capturing light from billions of years ago. It allows us to piece together the universe's history.
It's mind-blowing when you think about it, that we can look at light and see events that happened closer to the dawn of time than to today. That's one long-distance call. But does that mean we can see all the way back to the Big Bang?
Not quite. We can see incredibly far back, to a fraction of a second after the Big Bang, but not to the very beginning itself.
Okay, so no peeking into the universe's delivery room,
Yeah.
but we still get a glimpse of its early years.
Exactly. And it's in those early years where things get really interesting. While the Big Bang is the prevailing theory, even looking back to that fraction of a second after it occurred, well, it's like we're missing the very first frame of the universe's baby photo.
So what are the theories about that very first frame? What filled that space before the Big Bang as we understand it?
There are a few really interesting ones, and each one is pretty mind-bending when you really try to imagine them. One is the Big Bounce. Instead of a singularity at the start, it suggests the universe might go through cycles of expansion and contraction, almost like a cosmic heartbeat.
A universe breathing in and out, expanding and contracting. That's amazing. What else?
Then there's string gas theory, where the universe begins as this network of, well, strings, without our familiar notions of geometry. It challenges how we visualize space itself.
And what about colliding membranes? That one almost sounds like, I don't know, a cosmic game of pool or something.
Right, it's a wild one. But look, whether it's a bounce strings or a cosmic pool game, these are just theories. The point is, there's still so much we don't know about those very first moments.
And yet we can trace things from that fraction of a second onward.
Yeah, we see the universe expanding, matter clumping together to form stars, those stars igniting, and those stars coming together to form galaxies. It's this beautiful, awe-inspiring story of cosmic evolution, even if it's a story that ultimately, like all stories, has to end.
It makes you think, doesn't it? Even those dazzling images of galaxies we see, the twinkling of stars in the night sky. Behind them is this story of constant change, a movement towards, well, an ending. Which brings us to the concept of entropy, right?
Exactly. Entropy is like the universe's gentle but persistent nudge towards disorder. It's a fundamental principle governing how everything, from your sock drawer to the cosmos itself, tends towards a state of greater randomness.
So, like, no matter how hard we try to keep things tidy, the universe is always going to prefer a bit of chaos. Like, maybe a messy sock drawer is just the universe winning.
You could say that. Think about it. Imagine a drop of ink falling into a glass of water. It spreads out, right? We don't expect it to spontaneously gather back into a neat little droplet.
Never seen that happen, that's for sure.
That's entropy at work. Things tend toward what's most probable, and in most cases, disorder is more probable than perfect order.
So the universe is basically one giant cosmic latte, slowly mixing itself into a uniform blend, and there's not a single thing we can do about it.
That's one way to think about it. But hold on a second, because it gets a bit more complicated.
Oh, how so?
Well, think about life itself. Life, with all of its intricate structures and processes, seems to be fighting against entropy, at least for a while.
You're right. I mean, look at a single leaf, the veins, the structure, the way it captures sunlight. Or an eye. The complexity of that is unbelievable.
And the video does a great job showcasing that. It really drives home just how incredible and ordered life is.
It's like life is building these incredibly intricate sandcastles while the universe is slowly bringing in the tide.
A very poetic way of putting it, and it's quite accurate. Life, in a sense, borrows order. It takes in energy and uses it to maintain those intricate structures, to fuel those complex processes. But in doing so, it releases heat and other byproducts back into the environment, So ultimately, even life contributes to the overall increase of entropy in the universe.
So it's not that life breaks the rules of entropy, it just bends them a bit.
You could say that. We're all part of this grand cosmic dance, even as we momentarily resist its flow. But speaking of resisting that flow, how does it all actually end? What does the universe ruled by entropy actually look like when it reaches the final curtain?
So we've got this universe, right? And it's slowly but surely on its way to becoming one giant cosmic smoothie, thanks to entropy. But what's that final sip going to be like? What's the grand finale for a universe ruled by entropy?
Well, there are a few leading contenders, each one pretty mind-blowing in its own right. One scenario is something called the Big Freeze.
The big freeze. Sounds a bit chilly, even for cosmology.
Yeah, you could say that. Imagine a universe where stars, one by one, start running out of fuel like dying embers. They fade away, leaving behind colder, darker remnants. The expansion of the universe continues, but without the energy of those stars, everything just keeps spreading out, getting colder, darker. Eventually, you reach a point where temperatures are approaching absolute zero.
Brr, that is cold. So the universe basically becomes one giant, empty, and incredibly frigid place.
Essentially, yeah, a cold, dark, and eerily quiet place, almost like a cosmic ghost town.
Okay, that's one way to go out. But the video also talked about something called the Big Crunch, right? Is it the opposite of the Big Freeze? Like, does the universe suddenly decide to turn up the heat instead?
It's not exactly about heat, but it is kind of the opposite, in a way. Imagine this. Instead of expanding forever, the universe's expansion slows down. Then it stops altogether. And then, well, then things get really interesting because gravity stages a comeback.
Gravity. Wait, so instead of everything drifting further and further apart, everything starts coming back together.
Exactly. It would be like hitting rewind on the universe's expansion. Everything collapsing back in on itself. Galaxies colliding, stars merging, a colossal, unimaginable crunch.
Okay, I think I need a minute to process that image. Everything, and I mean everything, just crunching together. That's intense. But the video mentioned something about this leading to a new Big Bang, right? Like a cosmic do-over.
Some theories propose exactly that. It's a pretty mind-bending idea. What if the big crunch isn't an end, but just the beginning of another cycle? The universe expands, contracts, crunches, then explodes outward again in a new Big Bang, and the whole thing repeats, maybe forever.
Wow, okay, that is a lot to take in. A universe that's constantly being reborn, playing out this cosmic dance of expansion and contraction. It's almost beautiful in a way, even if it's also a little terrifying. But is that it? Are those the only two options, Big Freeze or Big Crunch?
Well, there is one more scenario we should talk about. It's a bit less known, and let's just say it's not as gentle as a slow freeze or as dramatically satisfying as a crunch. It's called vacuum decay.
Vacuum decay. Okay, now that sounds ominous. I'm not sure I'm ready for ominous right now, but go on, hit me with it. What is vacuum decay?
So imagine the very fabric of space-time, the very foundation of the universe suddenly becoming unstable, not just collapsing, but disintegrating. And not slowly either. It would be instant, unstoppable, everywhere at once, like a cosmic fabric ripped to shreds.
So no warning, no slow fade, just poof, gone, everything. Okay, I think ominous might have been an understatement. That is some next level existential dread right there. I'm starting to think the Big Freeze might be the best case scenario at this point. But seriously though, how likely is any of this to happen on a time scale that humans would actually care about? Like, should I be worried about vacuum decay hitting before my next birthday cake?
I can confidently say you do not need to worry about any of these cosmic events happening in any time frame that's relevant to human existence.
Okay.
We're talking about billions, more likely trillions of years in the future, even in the most extreme scenarios.
Okay, good to know. I was going to say, I haven't even finished that book I started last year. But this does bring up another question. If we're talking about these mind-bogglingly vast timelines, where does humanity fit into all of this? Are we just along for the ride? Or is there some chance, however small, that we could, I don't know, influence the show a bit?
That's the million-dollar question, isn't it? And that's where the video brings in a really interesting concept, the Kardashev scale. It was proposed by a Russian astrophysicist, Nikolai Kardashev, in the 1960s as a way to measure a civilization's level of technological advancement.
Technological advancement? How do you measure something like that on a cosmic scale?
Well, Kardashev focused on one key factor, energy consumption.
Energy consumption. So, like, how much electricity a civilization uses. Is that how it works?
That's the basic idea. It's based on the idea that a civilization's energy use is directly related to its ability to control and utilize its surroundings to achieve things on a larger and larger scale.
Okay, so the more energy you can harness, the more advanced you are. I can see that. So where do WE fall on this Kardashev scale? Are we at the top?
We're not even close to the top, unfortunately.
Yeah.
Right now, humanity is sitting at about a type 0.75 on the Kardashev scale. A type 1 civilization, the first major milestone, is one that can harness all the energy that reaches its planet from its star.
All the energy. So every single photon of light, every bit of solar wind, everything.
Exactly. Think about capturing all the sunlight that falls on a planet's surface, utilizing all the geothermal energy from its core, even harnessing the power of its weather systems.
Now that is impressive. Imagine the kind of things we could achieve with that level of energy at our fingertips. What's the next rung on the ladder? What does a Type 2 civilization look like?
A Type 2 civilization takes things to a whole other level, a level of engineering and energy mastery that would frankly blow our minds.
Okay, I'm intrigued and slightly terrified, which is my happy place. Hit me with it. What does a Type 2 civilization actually deal with that much power?
They wouldn't just be harnessing their planet's energy, they'd be capturing the energy of their entire star.
The entire star. Whoa, how is that even possible?
One theoretical structure is called a Dyson sphere, basically a megastructure built around a star to capture pretty much every single photon of light it emits.
A Dyson sphere. It sounds like something straight out of science fiction, which I am 100% here for, by the way. But I have to ask, what about a Type 3? What's left to conquer after you've basically put a star in a bottle?
You're right. A Type 2 civilization is already reaching levels of technological advancement that seem almost incomprehensible to us right now. But a Type 3, that's where things get truly mind-boggling. A Type 3 civilization wouldn't just command the energy of a star, they'd command the energy of their entire galaxy.
The entire galaxy. Okay, that's it. My brain's officially broken. Control over billions of stars. Imagine the kind of technology, the kind of knowledge you'd need to even conceive of something like that.
It's hard to even wrap our heads around, right?
Yeah.
It does make you wonder, though, if there's an upper limit. I mean, is there a Type 4?
A temper 5?
Or does it stop at controlling a galaxy?
You're reading my mind. I was just about to ask that. What's after a galaxy? The entire universe.
You're getting it. That's where those theoretical Type 4 and 5 civilizations come in. The Type 4, as you said, is a civilization that can harness the energy output of the entire universe.
So we're talking about beings who could manipulate the very laws of physics, create universes in a lab. Is that even within the realm of possibility, or are we just in pure fantasy land now?
That's the big question, isn't it? Where does speculation end and true possibility begin?
It's giving me chills, and I kind of love it. But what about a Type 5? I can't even imagine what's left after you've conquered an entire universe.
A Type 5 civilization, if such a thing exists, wouldn't be confined to a single universe. Some theorize that they would be able to traverse the multiverse, moving between universes like we might change channels on a TV.
Multiverse hopping civilizations. Wow. Just wow. It's almost too much to process, but it does make you wonder, right? Are we thinking too small? Maybe the universe or universes have some kind of escape hatch, some way to dodge the cosmic curtain call.
And that thought, that possibility, leads us right back to a concept the video explored that I think really throws a wrench into our whole understanding of endings. The idea that even in a state of maximum entropy, information might not be truly lost.
Wait, really? So even if we reach that point, big freeze, big crunch, whatever it might be, there's still a chance that something remains. I always imagined it as this point where everything just dissolves into static. Game over. Thanks for playing.
It's a common misconception.
Yes.
Maximum entropy, as far as we understand it, means a state of uniform distribution, minimal usable energy. But what if it's more like deleting a file from your computer?
Okay, I see where you're going with this. So you're saying the information, the data, it doesn't just vanish, it's still there, just harder to access.
Exactly. It might be overwritten, might be fragmented, but with the right tools and know-how, it could potentially be recovered.
Yeah.
Some physicists suggest the same principle could apply on a cosmic scale.
So even if our universe reaches a point where all the stars have burned out, black holes have evaporated, and everything's spread out, cold and seemingly empty, you're saying that the history of everything that ever was, every galaxy, every star, every planet, every fleeting thought, every grain of sand, it's all still there, just encoded somewhere in the fabric of space-time.
It's a mind-blowing concept, and it really makes you question what we mean by the end, doesn't it? It suggests that even with entropy, even with the universe seemingly winding down, something endures. Maybe not life as we know it, maybe not something easily accessible, but the echo of existence, the information that made up everything we hold dear, might persist.
That is, I don't even know the word for it. It's profound, humbling, even a little bit hopeful. It's like saying that even if the universe has an expiration date, the story itself never truly ends.
Beautifully put.
Well, we've covered some serious ground today, haven't we? From the potential endgames of the universe, the big freeze, the big crunch, even the terrifying vacuum decay, to civilizations harnessing the power of galaxies and the possibility that information might outlast it all. It's a lot to process, but I have to say, even knowing that the universe as we know it has an expiration date, even knowing that entropy might have the last laugh, there's something incredibly exciting about exploring these questions.
Absolutely. The very fact that we can ask these questions, that we can look out at the vastness of the cosmos and contemplate its fate, is a testament to the power of human curiosity. And who knows? Maybe, just maybe, it's in unraveling these cosmic mysteries that we uncover the key to our own next chapter.
What a journey. Thank you so much for diving into all of this with me today. It's been incredible.
The pleasure's all mine. Always happy to talk about the end of the universe.
And to everyone listening, thanks for joining us on this mind-bending deep dive. We'll see you next time for another exploration of the universe and all its wonders, beginnings, endings, and everything in between.